Hey y'all, for this month's re-release, we're going to revisit an episode from the first year of the podcast about
Whoa.
mosquitoes.
Back in 1983.
No, I was not born yet then, and neither were you.
That's true.
So the reason I chose this one is because, and this is a little bit of a spoiler alert, sorry, Jam.
Okay.
Next week's episode is also going to be about mosquitoes. It's Mosquitoes Part 4.
Oh, yes. Okay. Got it.
So you can listen to this one today, and then if you want, you can go back and listen to the other episodes. We also talked about why mosquitoes choose one person over another and what is DEET.
Okay. Interesting. And then we're going to be adding on new info
Yes.
about mosquitoes
Yes.
on next week's brand new episode.
Breaking news that we got tagged in a tweet from a listener.
Oh, cool. Okay. Sweet.
Mm-hmm.
So, yeah. Enjoy, you guys. And then we'll see you with the new hot off the press mosquito info next week.
I'm so excited to share that with you. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Jam, it's so nice to see you again in person after so long.
In person meaning in video, but yes.
Yes, I'm sorry. I meant in real time rather than text-only communication.
Totally. We're seeing each other and hearing each other, and it is live, and that's as good as you can kind of get right now anyway.
Except for our impromptu Target meetup, which was very exciting.
That's true. That's true. You can't plan that kind of stuff. That's just,
No.
That was very serendipitous.
It was. I was so happy. My face was so red in that picture because I was just full of joy. And that's what happens when I'm happy is I get flushed. And so.
One thing that was kind of funny too is I had enough time that I saw you kind of went past me at first. I had enough time to take a photo, which is kind of creepy, but take a photo, send it to our friend group text that we were already chatting with different people in before you noticed me.
Yeah, you creeped.
Which is always fun. We used to call that sniping, where you can, if you can take a photo of somebody and send it to them before they see you. But
you sniped me.
Yep, sniped you.
Well, are you ready to learn some chemistry? We've been on a little bit of a break here.
Yes, I'm very ready. I haven't had a chemistry lesson in probably 3 weeks, I would guess.
I think, yeah, it's been about 3 weeks. I kind of forgot that we even had a podcast.
Yeah. We kind of got ahead, which was great. But yeah, it's weird to then not have the weekly chemistry time in my life. So I'm ready for it.
Okay, well, this week is going to be the beginning of a series.
Nice. I like when we do series.
Me too. And our listeners, we took a poll, one longer episode or shorter episodes, and they said multiple shorter episodes is better.
Oh, nice.
We heard you guys. So this is going to be 2 or 3 parts depending on how the rest of the topics shake out. But Our topic is very, very summary.
Okay, nice.
It's a series on mosquitoes.
Oh, nice. Dang.
So why do mosquitoes bite people? Why do mosquitoes bite some people more than others? Why do mosquitoes bites itch? Why does insect repellent work? What's the best insect repellent? We're going to dig in to all these questions, and I've been getting a lot of them from a lot of listeners over the past few weeks. So
nice. Those are great questions. And mosquitoes are certainly a very, very infamous part of summer. So we're right in the heat of that for sure.
And I've been noticing other people getting bit a lot and me being around them and that not happening to me. So my curiosity was piqued, and then a bunch of people contacted us.
Mm-hmm.
So if you're one of the people that contacted us, I can't search our Instagram messages for mosquito the same way you can in your other messages. So I couldn't find all of those. So if you're one of those people and I'm not giving you credit, just message us and I will put you on there.
Nice.
But I think some of the people who asked was Vianette G, Mason K, Nicole B. There have been lots of people who have asked questions about this.
Nice. That's usually a good sign too. There's a few times where we've had like somehow all at once a few people asking about the same thing, or it's like, okay, this is clearly a good idea, a good episode, and we are interested too. But it's also like the people want it. The people are interested.
Right.
this is some chemistry that is in their life that they want to know about.
Oh, 100%. And I think, I haven't researched everything, but I think why the bites itch and how the repellent works is more chemistry related. Today's topic is heavily biology.
Okay.
So there is obviously chemical aspects because everything is chemicals. So carbon dioxide, our smell, all of those things are chemicals.
Mm-hmm. But
it's also biology topic. So as always, if there is a biologist or another scientist who studies this that's listening right now, please, please, please feel free to email us, touch base with us, let us know so that we can update this information. But a lot of it is also new. I found a lot of information from papers from 2014 and 2019.
Interesting.
So I think we're still learning.
Yeah.
Okay, we're going to dig in.
Okay,
we're starting. We're going. Okay.
I'm ready.
The first question is, why do mosquitoes bite people at all?
Amen. That's a great place to start.
Well, here's the thing.
Because if they didn't, none of the other questions would be necessary. So, yeah.
And this made me soften up towards mosquitoes a little bit. They're trying to get blood so they have a protein source for their eggs, to produce eggs. So they're just trying to get their babies born, you know?
Yeah. Hey, we try to do the same thing, don't we?
I know. You're just trying to get some life going for your kids. That's all you're trying to do.
Yeah. Interesting.
So I was like, okay, I guess that's an acceptable reason to bite people. But then when you think about the fact that that means there's going to be more mosquitoes, then you don't want that anymore. But I kind of get the instinctual drive, you know?
Right.
So because of that, only female mosquitoes bite humans.
Wow. Dude, that's crazy. I did not know that.
Neither did I. I thought it was one of those fake facts that people share, you know?
Yeah, fake facts.
But it's real.
Fake facts. That sounds like a little bit of an oxymoron.
People will be like, interesting fact, and then it's something that's not true.
Yeah.
So that's why they bite people. But then the next big question on scientists' minds is, how do they find humans to bite?
Mm-hmm.
So what have you heard?
Okay, well, I'm kind of in the same boat as you. I don't get bit a ton by mosquitoes. Like lots of times, but I do get bit some. But people will be like, "Man, I'm getting eaten up right now," and I'm like, "Oh, I've seen a couple, maybe."
Yeah, me too.
Usually, it's others around me, and so I've certainly heard things about blood type. In fact, I was just hearing people talk about that the other day, about supposing that some blood types are more appealing to mosquitoes than others. No idea if that's true. But that might be the only, I mean, maybe there's some sort of, it's the only thing I think of that might make a difference. I mean, I guess they could maybe smell us, but I feel like I can't think of any reason why they prefer one person over another unless it had to do with something about our blood that benefited them.
Okay, well, I have heard that too, the blood types. I've heard also that it has to do with CO2 that you express in your skin.
Oh.
And I've heard that is because your blood is sweet. You know, moms always say that to their babies. They're like, it's because your blood's so sweet. It's because you're so sweet. But that's not it. Sorry, moms. It does have to do with sweat.
Okay.
Carbon dioxide is involved. And that's pretty much it.
Nice. So not blood type.
Not blood at all.
That's awesome. Great.
Mosquitoes use carbon dioxide, body odor, and heat to detect their prey.
Okay.
So you're right about them smelling us.
Okay.
They can smell us, but the warmth of our bodies and the carbon dioxide are important.
Okay, got it. So if we were like super cold, they might pass us over?
Maybe so.
Interesting.
There was one study where they put out blood with human odors in carbon dioxide and kept the blood at room temperature instead of being warm, and the mosquitoes did not eat it.
Whoa. Interesting. Dude, that's so weird.
I know.
So they can like sense our heat in some way? Maybe that's too much of a biological question. Can they see it or?
Well, let me get into it here.
All right.
I jumped ahead a little because you asked the question, so I was excited to answer, but
Okay.
the carbon dioxide seems to play a role in that heat sensing.
Okay.
So I used to think also that carbon dioxide came out through your skin. Every single article I read said it was just the carbon dioxide that we breathe out.
Oh. Huh.
So the carbon dioxide that we breathe out has an effect on mosquitoes.
Okay.
And one study, they sort of figured that out, knew that that was probably it. So one study basically just inhibited their carbon dioxide in receptors. The same way we talked about the carbon dioxide receptors on our tongue, how they inhibited those.
Yeah.
They did that to mosquitoes. I think they genetically mutated them. So they actually did work on changing the DNA of the mosquitoes, which is crazy.
Yeah, that's crazy.
And they inhibited their ability to sense carbon dioxide. This was in one study in 2014. And when they did that, in the presence of CO2, the mosquitoes who still had their carbon dioxide sensor had more movement than mosquitoes without it. So something about their ability to sense carbon dioxide gave them a better ability to move.
Huh.
And they had, the ones without the carbon dioxide sensing had less attraction to human body temperature in the presence of CO2. So it's almost like that study says, in the presence of CO2 detection, they can move more and they can sense body temperature more.
That's kind of the most primary important ingredient. And the other things are kind of dependent on it.
Yes. Now, I should say, in that study, when they actually stuck a human arm into a place with the mosquitoes, the ones with and without the CO2 still were able to find the human and feed on it. So there's more than just CO2. It seems like from that study, there's more than just the carbon dioxide and the body temperature. So then you get into deeper studies and try to kind of figure out what else it is.
Yeah.
And that's where this 2019 study came in.
Okay.
This 2019 study, they dug into the human odors. They found a receptor on the antenna that seemed to play an important role.
Okay.
And they disabled it. And this receptor detected for volatile acids on our skin and in our sweat, such as lactic acid, or they're known as carboxylic acid. It's a special functional group. We've talked about functional groups. So it's just a collection of atoms. So it's a sort of a classification of a certain type of acid. And when scientists disrupted that ability to sense lactic acid, those mosquitoes had a reduced attraction to human host.
Whoa.
And the presence or absence of CO2 also played a role in that. So it seems like from all these studies I read, there's so many studies about this, that the chemicals in our sweat, plus the chemicals that we exhale, and our body temperature all contribute. They all have to coincide together for the mosquitoes to be able to find us.
Wow. It sounds like if you knew all that ahead of time, it seems like there's a lot of reasons. There's a lot of factors that have to be right for them to find us. So it almost makes it seem like it's harder. Like it'd be harder for them to find us. But then in real life, when you're outside in summer in places like Texas where we live, it seems like they're everywhere. But you just wouldn't think about it being that complicated.
Yeah, you really would not think about it being that complicated. And it's interesting because they would isolate something and it would show an effect, in the presence or absence of CO2, for example. There was that effect in simplistic studies where they wouldn't be attracted to blood or human body temperature without CO2 or whatever. But then you put a real human in and there's so much more going on that they're still, even without their ability to detect CO2, they're still coming at the human.
Right.
And then those scientists theorized maybe CO2 is like the first detection symbol, the first detection element, I guess I should say. And that indicates to them that there's prey nearby and then they can hone in. So when you're already very close to the mosquito, all your other things, your odors, the lactic acid, the volatile acid in your skin, your body temperature, that's more important. That's overwhelming to the mosquito's senses, and you don't need the CO2 detection anymore.
Mm-hmm. Got it. Okay, got it. That makes sense because like any mammal pretty much would be exhaling CO2. And so it'd be a really good first detection kind of thing. It's like, is something around that I could go get some blood from? Something that's in that broad category that might work for me.
There was some studies, it seemed, or some of what they were looking into was how they're so attracted to humans. Mm-hmm. So there was some studies on that, but I'm a little foggy on the details because that was heavy into biology papers that were just barely in my ability to grasp. So, and this really matters because mosquitoes can carry diseases with them that can kill a lot of people. Mm-hmm. So this may seem to some people like they're doing this research just to find out about this a nuisance kind of that bothers us. But actually, these are life-saving things to learn about because if you learn how mosquitoes can detect humans and come towards them, then you can use that to develop other chemicals or other things that can repel them or that can keep them from being able to impact humans. And then you're really saving lives from keeping them from transmitting diseases. There was a number, I should find it in the future, but for one of the next episodes, but they gave a number in one of these papers that said how many people can die of diseases transmitted by mosquitoes every year. And it was crazy.
Oh, wow. Yikes.
So, yes, there's definitely, this research is important because of that we're doing more than just keeping the annoying bugs off of us. These researchers are trying to save lives by doing this stuff. So
that makes sense. I wouldn't have thought about that primarily. I would have thought about it secondarily.
Right.
Like they're annoying and they are like just frustrating. And we, for the most part, as humans, anything that kind of bugs us that we can figure out a way to prevent, we just kind of do about nature. Oh yeah. Bugs us. Yeah. So that's what I would have thought of. But yeah, you're right. Like the disease part is probably huge. I didn't know that. I'd definitely be interested to hear that statistic.
Yeah, I'll be sure to bring that into the next episode. But also, they talked about, now that we know this, in the lactic acid paper, they mentioned, now that we know this, we can utilize this information to develop better methods of keeping mosquitoes away from humans, including putting lactic acid mosquito traps, or, they mentioned a few things that you're just like, oh, yeah, I guess that is what, the more knowledge we have, the more we can protect ourselves against this mosquito.
Yeah. Dang.
So that's it. There's 3 factors that we can easily identify and talk about. I'm sure it's a much more complicated issue than this, but these are the 3 main things that scientists seem to have reported on at this time. I'm sure we'll learn a lot more.
Okay, so it's primarily carbon dioxide, right? So mosquitoes are flying around, and the thing they seem to be looking for first is some carbon dioxide, which gives them a sense that some prey is nearby that might be worth further investigation.
Right.
And then the next one was body heat, right?
I don't know.
Was it not really in order after that?
There wasn't really an order.
Okay.
It did seem that the carbon dioxide was the first detection, almost the first signal that something was happening. But after that, it seemed the other ones were just all sort of together.
Okay, so body heat and then odors from our bodies, like lactic acid and potentially other things that contribute to an odor something that they can detect from us.
Right.
Which helps them hone in on us specifically.
Yep.
So that could that, maybe we'll get into this later or whatever, but could that make the difference then? Like, okay, obviously all of us are breathing out CO2, but when it comes down to the mosquito choosing between you or me, body heat and lactic acid or whatever else, do they make distinctions based on that? Or do we know, or what?
That is a question for next week.
Oh, okay.
So I'm going to leave that on the cliffhanger because the reason why one person over another is chosen is going to be another episode.
Okay, sweet. I like it. A little cliffhanger there.
A little cliffhanger. So we're going to talk about, in the next few episodes, we're going to talk about why some people are chosen over others. We're going to talk about why they itch at all. And we're going to talk about how to repel them.
Nice. Okay, sweet. I like it.
But I figured short bites would be easier than big bites, especially because this first topic is so biology heavy. Although the lactic acids, the functional groups in the acids that are volatile, that's chemical based, and the carbon dioxide that we breathe out, that's a chemical sensor. So the mosquitoes have chemical sensors that are indicating that humans are present, but the identification of the sensors and doing genetic engineering to remove those sensors, that is very biology.
Nice. Also, I like what you did there, and you said some small bites and some big bites.
That was an accident. I just set you up to take those swings,
Yeah, I wish there was an easier pun with the word mosquito. I'll try to think and incorporate one over the next few weeks. Bite seems like it's a little bit on the nose. It's still funny, but I'll see if I can find a different one that you don't see coming.
Well, good job. That was it.
Sweet. I like it. I'm interested in this series for sure, and there's a lot of questions about it. I'm glad we're taking it one at a time. Seems like they all are worth their own section, so to speak.
The only thing I want to add is to remind you that the CO2 detection also seems to impact their movement. So the ability to sense CO2 seems to hone their movement and detection of human body temperature.
Got it.
It seemed, as I was reading, it almost seemed like CO2 was sort of a gateway that opened these other pathways. So CO2 plays a role in the detection of the lactic acids and your ability to move and get body temperature. It's not everything, but it does enhance those or play a role or do something to make the mosquitoes be better. But really, the ability to do all of those things at once seems to be the best option.
Got it. Okay, got it.
Well, that's all I have for you. Do you want to share the number one most exciting thing that's happened to you in the past few weeks?
Totally, yeah. So we've talked about it a ton. I mean, it's obviously been a long time coming, but our baby got born. So
yay!
We had our baby about 3 weeks ago, and we had just enough heads up that we're kind of able to get ahead on podcast stuff. Just enough to not miss a week.
It was very close at the end.
Yeah, he came a little early, but all was well. Everything went well. Still adjusting to life with a kid. I mean, anyone who has a kid knows what that's about and knows way more than I do about how long it might take me to adjust. But yeah, just adapting and getting used to taking care of a little one that can't do anything for himself. So, but yeah, it's great. I'm loving it.
I think my happy thing is that I got to meet him through a window.
Yes.
I was so happy. And I got a video sent to me where Emily was talking about chemistry for your life and he was smiling.
Yeah.
She said intermolecular forces and he smiled. And she said, "Do you love it?" And he just looked so happy. I've watched that video so many times.
Yeah, we try to do whatever we can to see if we can get him to smile. And it seems like tone of voice is a big part of it. Then also sometimes it seems like something that enters his own head, whatever, I'm not sure what baby thoughts are like, will just make him smile out of nowhere.
No, it was because of chemistry for your life. It was because of intermolecular forces.
Yeah, definitely.
Definitely.
For sure was that.
Well, I really loved all those videos, and I know that he smiles because of intermolecular forces, but some parents are being pretty careful about putting their kids' images on the internet. So what are you guys thinking? Do you want to be able to put a picture up, or?
We're not totally sure yet. We haven't really thought through that a lot, honestly. But we're going to try to figure that out. So if you guys end up seeing a photo, then you'll know what we figured out. And if not, it might be that we just do that a little bit later, or we space it out so that he's not like, all over the internet his whole childhood kind of thing.
Right.
Just hard to know. Like, I wish I had a good resource to follow on that, but we're trying to be careful until we kind of decide what seems right. So yeah.
Right. It's hard because there's a whole generation of kids whose whole life was on Facebook and Instagram and stuff.
Yeah.
They haven't really become adults yet, so don't really know.
Right. And like, I got to decide what was posted about me, but only as far back as like high school when Facebook happened or whatever. So there's my whole earlier than that childhood was just private, for our family or whatever. So it's just kind of interesting to think through. So we'll see, but hopefully we can figure that out. And if any listeners have any good thoughts or resources or books or something like that on that topic, I'd certainly love any recommendations. So
yeah, definitely
send those our way.
Well, congratulations on being a daddy, Jam.
Thank you. Yeah, thanks. I'm loving it.
It's so fun.
It's awesome. It's so far as awesome as people will say. So
yay. Well, I wish I could be there and hold him and snuggle with him, but due to coronavirus and us all trying to keep safe, I will continue to stare at him through windows whenever I have the chance.
Perfect.
All right. Well, thanks so much for taking time out of your dad's schedule away from your precious baby to hang out with us and to learn about mosquitoes. And thanks to all you listeners for coming and learning about mosquitoes as well.
Well, thanks so much for teaching us and for starting this cool series. I'm excited about these future episodes. And I'm glad that we're back to recording and having some chemistry in my life on a weekly basis. So Melissa and I have a lot of ideas for topics of chemistry in everyday life, but want to hear from you, just like mosquitoes, which we heard from a lot of you guys. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you aren't able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to S. Flint and V. Garza, who reviewed this episode.